So this is actually a very interesting topic. This greedy algorithms and optimization for a business analytics professional, because it hits the real world so often, and optimization is something that you can think about on a daily basis and use to help solve problems. And we'll go into a few different ways that I personally use this all the time, and I'll explain some of the ways I use it. So we're going to be, again, talking about this concept of optimization. And one of the things that's interesting about optimization is in the real world, a lot of times there is a choice, a binary choice between a non-perfect solution and then we also have a solution, no solution. And that's really one way to think about it, is that a lot of times these are the two choices that you're faced with when you're trying to solve a problem. And so, unfortunately, many people choose to not solve a problem because they are trying to make it perfect. Instead, though, a better way to think about this would be to think about, can I come up with a non-perfect solution? So a good example of this is this traveling salesman problem, or TSP. And in general, the concept is that if you have a bunch of different cities that you're going to need to visit as a traveling salesman, how can you visit them in the most efficient way possible, right? So that's really the core concept. Is if we had like a section of the world and we have all these different cities, and we could just pick maybe the Bay Area, right? So we could say this is San Francisco, this is maybe San Jose, this is Santa Cruz, this is San Luis Obispo, SLO, right? It's a problem where there isn't a perfect solution to it, because of the fact that the complexity to solve it grows in a way that is uncontrolled. And so instead, a different approach has to be used to solve a problem. And this, again, does come up in the real world quite a bit. And so what is one of the ways that you can use to solve this problem is you can use a greedy algorithm. And a greedy algorithm, what's nice about it is that you can use essentially a heuristic. And the heuristic is one of the ones that I've used before, is that you randomly start. So that's the first part. And then you always pick the shortest distance, right? And so shortest distance. So what does this do? Well, this is actually an intuition that you can think about, which is that if you accept for a second that there is no way to solve this problem in an efficient manner, and you could be basically trying to solve it forever, if instead you use a heuristic like this, it actually turns out that if you do a simulation, and we take this greedy algorithm, randomly start, pick the shortest distance, you can run a simulation, and the simulation will always get different results. So in the simulation, let's say that it finds 25 cities, and then it could actually pick a total distance of 100 miles. That could be simulation 1. And then you could do another one. It could be simulation number 2, and that could be 30 cities, and maybe that's 125 miles. And so what you do is you just keep running the simulation for however long you have. Maybe you have a day, so you run it for a day. Maybe you have it for an hour, and then you just minimize the shortest path. So this heuristic goes through, and it does 1,000 iterations. Eventually, you find one that's a good enough solution. So the concept here is that, and in fact, it even goes into an intuition that you may have heard before, which is that perfect is the enemy of good enough, right? And this is really an important concept: is perfect is the enemy of good enough, right? So again, if you're faced with this dilemma of, do I not come up with a solution, or do I come up with a solution that's pretty good, right? And that's really the core of optimization. Is this concept, and to explain how this happens, let's get into something called Big O notation, which you may have heard of. This is a really common way to ask programmers, for example, about whether they understand how to write efficient code. So if we look at Big O notation, it's related to optimization. And what Big O notation does is it gives you an intuition about the code that you write. And we can actually, in the real world, see some very good examples of Big O notation, at least the fundamentals of it. And a good way to think about it is COVID-19, right? That's probably the one where there were, if we look at a notation which is O to the 1, which is basically every single time I run an operation, I get the same result. It's a fixed lookup time. This is actually a dictionary in Python has this, right? And so what this means is that if I look up a result out of a dictionary in Python, I always get the same time, right? So it could have either 1,000 items in it, or it could have 1 million, and it's still going to take, let's say, 20 milliseconds to get a result. So what does that look like on a chart? It's literally like this. This is just this. So no matter what, so this would be the observations right here. So we'll just call this observations. So in the case of O to the 1, this is great because no matter what you do, you always get a great response. A lot of things are not like that, though, in terms of computer programming. And a different example of this would be a list. If we look at what a list is, a list would be O to the n. And O to the n means that you're going to, the amount of time to process it is directly proportional to the amount of observations. And so what that would be linear. So we have a linear growth rate, which would be, again, O to the n. Now this starts to get into, like, if we think about a linear optimization problem, that if we had if we were able to come up with a solution where we just processed the amount of cities, and for every city it just took a little bit longer, that wouldn't be that bad. But unfortunately, there's even worse than this, and the worst is we could just call this in general superlinear. So superlinear means that the growth rate exceeds linear, and so again, we all know, the whole world knows about this now, which is this is superlinear, which would be exponential growth. We'll just call this exponential growth. Has properties that make it so that eventually, if you have something that's taken a long time to run, you'll just get to a flat line, right? Because it gets faster and faster and faster in terms of the stuff that that it's accumulating. So this also fits into the problem of something like the traveling salesman problem, is that it's there isn't a solution that doesn't get into this super linear growth rate here. And so this is really the problem, is you have to come up with another way to solve the problem other than just trying to find the perfect solution. If it's linear, then there are solutions for linear optimization problems. But if the data itself is nonlinear, you have to use heuristics. And this is where the greedy algorithms come into play. And a very similar problem to this is something called the knapsack problem. And the knapsack problem also is something that is very intuitive that comes up, and we'll just draw that up here. Knapsack. And the knapsack is basically if you have a bunch of different things that you're going to put into your bag. So here's your bag here, and it can only hold, let's say, 45 pounds, and you have a 10-pound item, you have a 15-pound item, and then you have 25-pound item. And anyway, what's the most amount of items? Maybe a 2.5 pound item here. What is the most amount of items that you can put in your bag, right? Is it's a way of packing things into a solution, and an iteration of this is something called the greedy coin problem. And what this means is the same thing. Is, let's say that you are building an algorithm, somebody hires your company to build a vending machine, and here's our Coke machine here, and you need to come up with a way where when people put in their money inside of this Coke machine, we'll just call this Coke. When they put the money in, let's say they put in $1.75, you need to give them the correct change back, but you want to give them the big coins first, right? So you want to make sure that when you're going through here, that you first give the 25-cent pieces, then you give the 10-cent pieces, then you give the 5-cent, then you give the 1 penny, right? And so this is also a problem of how do I figure out a solution that dynamically grabs some values, tries it out, sees where I'm at, and then dynamically grabs the next values. So it's got a relationship with this traveling salesman problem. So in general, why do we care about these kind of non-perfect solutions here? Is that a lot of times, as I mentioned, in the real world, that's how things are. And a really good example of this would be, you can try this algorithm yourself out, which is if you're in a city, a large city, and this is the intuition. Let's say you're in a city and you have a huge amount of streets, and you have this, you have maybe this, you have some kind of streets in a city. One of the things that happens a lot in a city is that, let's say you start here, this is point A, and you need to go to, let's say, point B here, and you start walking. Well, first of all, you start walking this way, right? You start walking here, but then it turns out that that's a traffic light, right? The light stops you. Well, one of the things that you can do is, that you have to go there, is you could just wait, and then you wait, 5 minutes, and then you start walking, and then you go again, and then you wait another 5 minutes, right? And then you go here, and then you start walking up here, and then you wait again another 5 minutes. So let's just say it takes you 20 minutes if you go like this and then you go straight up. But maybe a different approach, which there isn't necessarily a perfect answer because you don't know when the traffic lights will happen, is what if instead every single time there's a traffic light, you just turn, right? So that's a heuristic is, I have a traffic light. Why don't I just start walking? As long as I don't exceed here, I'll be okay, right? Is I could just keep walking. And in fact, I could use a couple of different approaches, but I could just walk here and then, and as long as maybe, and you could kind of use your own intuition here, but basically, why don't I just keep walking until I get a light? Now I got a light. Why don't I walk again? Right here. And then let's say I get a light, then I just walk up here. And then I get a light and I walk up here. And then from here I can finish it. So basically by using a heuristic, which isn't perfect, this is actually a great way to go to the city, is there's lots of different ways that you can travel to get to your destination, but why would you wait? Right? Like if you can always go to left or right, why would you wait at a traffic light if you want to get somewhere fast? Instead, always turn, because you have lots of opportunities. You have essentially an almost infinite amount of possibilities. So use a heuristic, which is always pick the optimal choice when presented. It's either, if you have two choices essentially, either stop and wait, which is slow, or turn and keep walking until you're stopped again, then turn again, right? So again, intuitively, this is a greedy algorithm, which is when presented with the best choice, choose it. And typically, if you do a bunch of simulations like this, you'll have a quicker route than trying to optimize for some perfect route. And so that's really, in a way, similar to the intuition behind a traveling salesman problem. And so what I will do next here is start to get into. So now that we know the intuition here, let's get into a couple of different code examples. And one of the ones that I'll get into is, let's go to this one here, is this Google link is a pretty good one. This particular example, which is get started with OR, or operations research. So what is an optimization problem? How do you solve the optimization problem in Python? So as I mentioned before, the goal of optimization is to find the best solution to a problem. But sometimes, and this is what I was referring to, you'll be satisfied with finding any solution. So again, if you're in a hurry in the city and you're trying to get somewhere because you're meeting a relative, or your family member delivering a baby, you're not okay with taking the longest amount of time. You may be okay with any feasible solution, and so maybe you can try the one I came up with, which is always turn when you're at a stoplight. But a typical optimization problem is that you have a fleet and you want to deliver packages across the smallest total distance. And this is actually something that many companies are involved in logistics. So the optimization problem has the following characteristics. So the objective is the quantity that you want to optimize. And so this is the objective function, and it could be minimizing the cost, it could be minimizing the distance, it could be minimizing the coins that you're going to give somebody. And then the constraints would be restrictions on the set of possible solutions given the requirements. So in this example, the shipping company can't assign packages above a given weight, right? Or in the case of the change machine, you can only give 25, 10, 5, 1. And so a feasible solution, though, is one where it satisfies all the constraints, but it doesn't necessarily have to be optimal. It doesn't have to be the perfect solution here. So there's a bunch of different libraries in Python that do linear optimization. And in fact, I'll just bounce back and forth here. There's another article that I wrote. I think I put a link to it here. No, I'll put it here. It's called IBM Developer Works Linear Optimization. And this is worth talking about as well. And this is an article I wrote a while back. And if you think about, make this a little bit bigger. If you think about optimization here, models are used to explain phenomenon, predictions, assess key factors, trade-offs, and one thing that we're really talking about in this course is that you don't necessarily have to be a proficient programmer to solve problems in data science and business intelligence. In fact, things like Excel or spreadsheets or off-the-shelf no-code or low-code tools work very well as long as you can just think through the problem. And the thing that's great about a spreadsheet is that they're very intuitive, and you can do linear optimization in a spreadsheet. This one in particular talks about something called Pyomo, which is a little bit of an older library. And the example I'm going to show you in a second is probably a better choice. But one of the things that I wanted to show you in this article here is that if this is the main takeaway, is that you can think of actually programming in three ways, and so it's this particular example here, which is a spreadsheet. You can put in a sum, and it's actually x1 to x6, but in algebra you can actually do this in symbolic notation, or in Python you can say sum range 1 to 6. So you a lot of times it's someone is stuck on one of these. Like if you're a programmer, you just know about Python, right? And if you're a mathematician, or you're used to academics in school, you're used to drawing the symbolic notation in algebra. Or if you're a spreadsheet person working in a company, you typically only use a spreadsheet, but they're all the same. They're the exact same thing. And once you start to think through the problem and realize that you can solve a problem in a spreadsheet, you can solve it in algebra, or you can solve it in Python, then it kind of demystifies some of the issues here. So I think that's one other big intuition when you're dealing with business intelligence, is that you shouldn't feel forced to use Python or be forced to use a spreadsheet or forced to use symbolic notation. Is that they're all related. There's just a different way of expressing the same idea. And again, this is the main thing that I wanted to show you with that. And then the let me go through and talk a little bit about the traveling salesman problem. So as I mentioned before, we know that there isn't an optimal solution for it. There's books and books and books about this, but the core concept here is that if you build something that involves simulations, that has that algorithm I mentioned, which is randomly start somewhere, always find the shortest. If I have two choices or three choices, always pick the shortest one. You can see that a traveling salesman problem is in fact super linear. If you try to solve it in days, all of a sudden it starts going again, just like COVID-19. If you don't understand exponential growth, and there's countries that did understand it and there's countries that did not, that exponential growth goes out of control. So the same thing with traveling salesman problem is that if you naively try to solve the problem, uncontrolled time growth, and you'll never solve the solution. It'll run there forever. And so the number of cities here, once you start to get to a certain amount, it's an infeasible problem. So you have to come up with another solution. And as I mentioned before, this is another strategy that's good, but not guaranteed to be optimal, is if you keep running a simulation. So here's actually some code that that I have written to solve this problem. And you could pass in a number of cities and the distance between those cities, and then go through and run this simulation. So in this particular simulation, I say run my greedy random start algorithm, run it 20 times, and then it comes up with the shortest distance, and it shows me the different cities that have happened. And so how do I do that? Here's an example of the way the code works is that I say from random import choices, and then I take in an array in NumPy. And you could just think of a NumPy array as just spreadsheet, right? It's just columns in a spreadsheet. And then I pass in these cities right here, just like this. And again, this is just the distance between the cities. And then I iterate through. And so I think I have, that's the whole list. And then if I go here, we can see the actual algorithm, which I can walk through again, which is fairly intuitive. Is that I say, while true, I walk through the cities, and then I just always get the shortest route, right? So I just always, if I have a choice between two, I always pick the shortest, and then I add them to the itinerary or cities visited here, and then at the very end, you just say get the total distance, and then you add this simulation, which runs it over and over and over again, and you just put in the number of simulations that you want it to work. So let me show you a couple of these things here in a Colab notebook. So if I went to a Colab notebook, which is a good place to try these ideas out, I could actually start using these concepts for a lot of different solutions. So I'm gonna just say explore greedy ideas, explore greedy solutions, and then what I can do is I will check this into that operations research notebook. So I'm going to go here. And I'm going to go to operations research. Okay, where is OR? There we go. OR, operations research. So I can kind of go back and forth here and check things in. So a few different things that I'll do that are important to talk about is just knowing how to do randomness is a good idea, because it's an important part of building these non-optimal solutions. So how do you do that in Python? So let's just build this out. Let's just say, how do I use randomness? Well, fortunately, in Python, it's pretty easy if you use list and you do choices. So if I do, for example, let's build out some choices here. So I'll just say food, and we can do an apple, a banana, and then a strawberry or something. There we go, strawberry. So fortunately in Python, it's pretty easy to build a random script here. What I can do is I can just say from random import choices, like that, and then I can say choices, and then say food, right? And so in fact I can, and this is actually a pretty neat trick, is that if I just keep running this over and over again, it'll randomly give me a new choice, right? So this is a pretty good start to a lot of algorithms. And in fact, I guess I can say this how do I use rand? Woo. How do I use randomness in Python? Here we go. So, and I'll just check this in so that other people can see it. So we'll check a copy of this in. Hopefully it remembers the last spot. Of course it doesn't, which is irritating. Okay, so there we go. But one trick that you can do here that actually is a pretty neat trick that you can do if you want to integrate something like this in a piece of code is you can also do infinite random, lazy infinite random. So how would I do that? Well, one way you can do this is, we'll call this, what about lazy infinite random? So what I can do is I can make a function that says return forever. And what it can do is it can have return food forever. How about that? And I can put in this food here like this. And what I can do is I can say for meal and food, yield and I guess to be complete, I'll put this all in one block. So we can what we can do is we can say yield choices food. So why would I do this? So if I wanted to build a simulation that ran forever, that was giving me random choices, I could actually go through here and randomly call this function over and over again. So how would I do this? So if I say for results in range 10, or let's do 3. Let's just do 3. I can say return prints. Actually, I think I could just call this, just say return food forever. So basically, I think I have to just say next. Is it prints? Let's see, prints. Yeah, so we have to do this. Next, I think that's right. Next. There we go. So basically, what this does is this will always, I can call it as many times as I want. So I can call it 6 times, for example. And wait, but how did that work? Right? Because there's 3 items. There's 3 items inside, and the reason why this works, and I could also just do it manually too. I could just say next return food forever, and the core idea here is that because I'm using Python has something called a yield. You can yield a random. You can yield something forever because yield is something that never stops until it is out of values. But because in this case random runs forever, so this is just a neat little trick that you can do if you are going to build your own simulation, especially a random simulation. This is a great way to do it. If you always wanted to randomly pick some kind of a value, you could easily build out just in 5 lines of code or so, or just a few lines of code, a random number generator that runs forever. So let me show you another thing So I'll just save this again, save copy in GitHub, so other people have an example of this, so you can play around with it. I think actually the way to save this, if I remember correctly, so that it opens on the same one, is that I can do this. I can, if I save it here and then I reopen it, I think it'll remember that I opened it from this location, I believe. And now what? Let me see if I save it again in GitHub. I believe it will remember the operations research. Oh, there we go. Yep, perfect. Okay, so the next thing that I'll do is so we know how to do randomness. We know how to do infinite randomness. Pretty easy too. Just a few lines of code. Even if you're new to Python, these are pretty easy to do. But what about a more complex problem like the change machine? Well, let's build that out next. So let's build out how can I generate the correct amount of change, right? So again, somebody hires your company to build a change machine algorithm. It's a little bit of a tricky problem because you have to, and it's changes depending on what kind of company or what country you're in, right? So we know that the constraints are that it's going to have to be first the largest coin, then the second largest coin. And again, because we have lots of different companies, lots of different countries, they have all kinds of different coins. So I have an example of this that I'll use here, which is, I think I have it in AWS Lambda. I have this change machine. So let's go through and let me look at this notebook real quick and I'll throw it in there. Okay, it's this one. Change. Yeah, so this is it right here. So I'm just going to first copy this, and later we can also, if we have time, put it into a cloud-based function as well. But this particular example, maybe I'll put a documentation string here. So we'll do this, and I'll just add a quote here, and we'll just use this as like an idea. So we'll paste this in and just say this is Python, and say this is an example of a web service that returns change. Okay, so I'm gonna just clean this up a little bit. So I think I just need to do, I just need basically this here. I just need this code. So I'm gonna build a function called change, and this one will paste this in here, and I'll just clean this up a little bit. So we basically want to put in the correct amount of change, like this. Actually, that's kind of irritating. Oh, if number, yeah, and then that will go there. Yeah, this looks good. So this will be, I'll take a value called amount, and then this will just be that variable amount, just like that. All right. And so then the coins as well, we could even put in the coins, like if we wanted to change this, that could be passed in here. And I think we can just return back the result. There we go. So hopefully that works. I don't have any bugs in there. looks like this, I need to clean this up a little bit. If the coins, that looks good. Okay, hopefully this works. So we'll just say change. If I put in $1.34, what happens? So it gives me back 5 nickels or 5 quarters, 1 nickel, and 4 pennies. So what happens here again, and what's great about using these kind of greedy algorithms is that there isn't a way to know all of the different perfect combinations here. And so what happens is that if I was building this algorithm out for a company, all the main things that I would just need to know about would be that you would need to have coins, which would be the denomination, so the quarter, the dime, the nickel, the penny, and then I would add in whatever the value is that I'm going to call them. So in this case, in the U.S. currency, these are quarters, but in a different country, they could be a different currency. They could be whatever the name is. And then this is the part that's the tricky part, is that we import. Now I need to put this in there so that we from decimal. I guess this is built in. I don't even need decimal anymore. So, but I use this thing called divmod, which essentially gives me the number and the remainder for a coin. So basically, I take the amount and I put the amount and I look at the coin and I get the number and the remainder, and then I put whatever's left back inside of this. And then I say, as long as the remainder is greater than 0, then keep popping the coin. And so what this does is it always starts with the largest coins, and then it works its way through there. So what's great about this is that it uses this greedy heuristic to solve my problem. And it's very non-deterministic, and it works with any problem. And in fact, I think we even could add a print statement to show you how it would work. So if I go through here, and I could say, and add an F string and say, this is the num. Like this, and we could put in the number, and this is the remainder, like this. There we go. So in this case, you can see that here's the number, here's the remainder, here's the number, here's the remainder, here's the number, here's the remainder. You can see that it's walking through this amount and finding greedily the best solution by iterating through and popping the coins out to find the right coin. And in general as well, we can use this for a larger solution. So let's just say if I go to 1134, right, we can say this is the number 45 and this is the remainder, right? So it first starts off with the largest possible amount of coins, and then it says, okay, well, what's left? I tried to do 45 coins, 45 quarters. Okay, now let's go to the next thing. Let's try that out. Okay, that didn't work. Okay, here we go. We can do a nickel, right? That a nickel would fit because the remainder is 9, right? So a dime wouldn't fit. So but a nickel would, then it tries the nickel. Okay, what's next? Okay, the only thing left is 4. Let's go ahead and try this. So this is again a great example of how you can use this greedy programming to solve problems. And again, it's a very small amount of code. So we can say, if we wanted to, you could take this and convert this into a web service, or you could build it into a command line tool. But I think in our particular situation here, it might be nice to take something like this and convert it into a command line tool. I'm sorry, into a web service, so that we could actually give this to maybe a company that we're dealing with, and they could see that the change machine algorithm that we developed will solve their problem, right? And again, because we use Python, it only takes us 10 or 15 lines of code to solve the problem. So that's what I'm going to do is I'm going to check this in here, and I'm going to save this into GitHub, and then I'm going to build out a service using AWS that will solve this problem for us. Of course, there's actually 2 ways we could solve it. We could solve it with AWS, or we could also solve it with Google App Engine is another option. Let me think about this. I think let's try Google App Engine actually, because Google App Engine, we haven't done that one yet. So let's go ahead and try that. So I'm going to leave this one open, and I'm going to go to GCP. And one of the reasons I like Google Cloud for building business intelligence and business analytics is that it's pretty intuitive to build web services very quickly. And I have actually a account already. So I'll go through here and I'll say activate Cloud Shell. And the main thing that's interesting about Google, the Google Cloud, is that you can build web services that solve problems and deploy them all within one command line tool and just put them into production. All right, so it looks like it opened it up. So in this Cloud Shell environment, which is just basically like a regular terminal, you can see that I'm on this particular project called Cloud AI, and I'm going to look at another project I have, which is called GCP Hello ML. And one of the things that I'll do is I'll just run some of these commands here that I've got here. So one of them is that I can say, show me, describe the project I'm in. There we go. So it says active. And if I wanted to, I could set it to a new project, or I could create an App Engine application. So let's go ahead and create an App Engine application, which is just a basic web service. So let's see if this works. Looks like I already have one. So what I can do is just make a new project here. Let's just, if it lets me, I've created so many projects, it may be upset at me. We'll just call this change machine. Let's try that out. And okay, looks like it's letting me do that. Okay, and then I can just swap this to change machine. Here we go. And in general, we should be able to describe the, I want to switch projects. So I think the easiest way to do that would be to just open up the shell again, and it should associate with this new project. Oh, there you go, change machine. Okay, great. Okay, so now what I'm going to do is I'm going to just probably use this repo. So I'll go here, And I'll just check this code out. Go to this repo and say git clone, like that. There we go. Looks good. And then I'll cd into this operations research. There we go. Now that I've got inside of this repo, I can build out a Flask application that takes the stuff that I did before. And so I think I actually have an example of this that I could start with. Let's see if I have an example in here. Yeah, I'll just take one of these examples, which is this. I'll just grab something like this and I'll paste it into this shell. So there's a couple ways to edit something inside of here. You can edit in the shell, or you can also edit in the editor. It's probably a little bit easier to edit in the editor, and this will be the main.py file. So I'm going to say, actually, before I do that, let me run the create project command, which is app create. And what this does is create the App Engine application behind the scenes. Okay, so it's going to ask me, where do I want to build it? Let's just pick the central. So I'll pick US Central. Okay, so it's going to go through and create this App Engine app for us. Okay, that looks good. And then as long as I have the correct structure in here, it will deploy it. And the correct structure is a main.py file and then like a config file here. So I'm gonna create those. So I'm gonna say touch, maybe make this a little bit bigger as well. So touch main.py, and then the other file that it will want is this. It'll want an app.yaml file as well. So we can just grab that as well. So app.yaml. So touch YAML. Right. So pretty simple actually. Is it YAML? Let's double check. Yeah, YAML. So it just needs those two files. But I'll edit these in. I'll click this thing which says Open Editor. So if I go to Open Editor, I can scroll this up and go to OR and look at this app.yaml file, and this is where you would set the runtime. In this case, I'll just say the runtime is Python 3.7, and then for this main file, this is where I would put in the logic. And so first, before I build the fancy stuff with the change machine, I'm just going to get a hello world to work. So I think I have an example here of a hello world project that I can use. Like I can just grab some stuff out of here actually. This looks pretty good. Let's grab all this and I'll just throw this into this application. So we'll just paste this in. So I can just remove things inside of here that are just maybe too much stuff. So I'll just get rid of this, get rid of this. So I'll just make a hello world Flask application. So the key, it doesn't look like we need this. Logging is imported. Let's just yeah, I don't think I need this for right now, so I'll just get rid of this. Okay, so this Flask is a web service framework, and to make a very simple web page, it's just a couple lines of code. It's a function, and then you put a decorator on top, which is another function with the route that you want to go to. And this one will just say hello world. And so I'm going to save this, and if I go back to the terminal, I can just run this locally. So I can do this. I can just say Python. Now, but before I do this, though, what I typically like to do well, actually, we don't need to do this for now. Is notice that I have a Python virtual environment sourced. I won't get into that just for speed today. But basically, it's a good idea to have your virtual environment sourced.
I don't know that.
It's good to have your virtual environment sourced so that you have a version of Python that installs everything into a certain directory. But for now that works, if I just say Python main here, it's running locally, and I can actually go to this web preview icon here, and this web preview icon will let me test out this web application right inside of the shell. So if I click on this, I can say preview on port 8080. There we go. And now we can see that the application is running. Right, so, and look, I even can see the log files. And even further is that I can actually edit this in real time and test it out. And it can just be staying there. So I can even say like, I think inside of here you could say print I am inside hello world. If I save that, it's still running this web service, and if I run it again, it still works. And if I go to the terminal, you can see that it's reloading, and look, it says I'm inside of hello world, right? So it's kind of neat that you can kind of change it. So from here, we can actually just test this out, this building our own change function using that algorithm that we came up earlier by going back and toggling this editor. So I just need to make another route inside of here that does the change operation. So how would I do this? Well, let's build this out. Let's go here and say app route change, and then we'll just call this change. Sounds good. And we know though that this change route probably would be best served if, trying to think what's the best way to do this. I think what we can do is we can put in like the dollar and the cents, right? So I think we can say dollar and then cent like this, which is pretty kind of a cool way to solve this. So we can build a REST-based service. And if I go back to this other code example, I think I have a couple of examples in here of that. Let me just grab another example where like this. So we know that this, for example, we can just kind of use this as a template. So if I just throw this up here, I can just look at it. So we know that I just can put this parameter here and it'll pull it out of the URL, right? So I can say that looks good, dollars, cents, maybe we'll say cents. So I just need to pass that in here. So I'll say dollar and then cents. And maybe to start with, I'll just print those out. I'll just print just so that I make sure that it even works. And so I'll say value is equal to this. And then I think from Flask, I'm going to have to import JSONify, which is all it does is return back JSON. So I'll go through here and do that. There you go. So we have JSONify, and I'll do the same thing that I'm doing here. So I'll put in dollar is equal to dollar, and then we'll say, in fact, we'll just say dollar value, and then this will be cent value. Cents value is equal to this. Cents. go. And from here, we can just return back the JSON results of both of those. So I could just say return JSONify, and just put a list of the dollar value and the cents value, like that. So basically, accept the stuff from the parameter, the dollar and the cent, convert it to JSON, return it back. Let's see if this works. And in theory, it's still running in the background if it didn't blow up. Let's see, is it still working? Okay, so we just need to restart it. So we'll go back here because I made so many changes that I have to start it again. Okay, it looks like it works. And so if I go back to this, or I can actually go to the web preview, it'll open it up again, preview. And now I just need to put in the change route, and then put in the dollar, which will say maybe is 2, and then for the change will say 34. So it should return back those values, and it did. There you go. Pretty nice. So I don't know why it opened up another window, but let's just do this again. Let's make this a little bit bigger. So we'll say change $2.50. There you go. Right. So we have at least printing the values back out. It accepts it and it prints it back out. So we're in pretty good shape now to finish the last piece to build out this business intelligence system that gives results out as a web service. So I'm going to now use that change algorithm that I looked at earlier, this thing. So it's pretty much ready to go. I can just copy it and paste it into this because we know. So I'm going to just get rid of maybe this because I don't care about that one anymore. And I just throw that in there. And what's great about this is it's pretty much ready to go. And it uses all built-in Python code. It's got everything included inside of here. And so we can just say, the only thing that I would have to change that these names are going to conflict. So I would say, I'll call this greedy change, like this. There you go, greedy change. And this looks like it'll return back a list. And so I can just do this. I can just say that I would need to assemble this into a string. So I would just need to say float. So let's just do this. Let's just print this out. So we can just say basically these values are passed in, right? And we can just do this. We can just say passed in, right? Which is just the list of those two dictionaries. And we can just say this. That'll just print in the terminal. And then under here, we'll just say, we'll take those two values and turn it into a float, which will be the decimal. So we'll say the amount, it will equal to float of the dollar and let's see, let me think about this. So I take this value in. Well, we could do I think you could use the decimal library here actually. Let me look at this. So if I pass in, if I say basically I'm gonna have a string that gets passed in. I mean, there's a bunch of different ways to solve this, but like if I say stir 3, I'll just do it in a sloppy way, which is I can say, if I said this, if I said float stir 5, what would that do? Float takes 1, so it doesn't like that. But what if I do that? Does that work? Has no attribute. So maybe what I need to do is format it. So I can say, I can do this. I can say results is equal to, and I can do an F string, and I could say, so let's say I get these two values. I have 1 is this, and then I have 2. How do I convert that into a decimal easily? I think what I can do is just do this. I can say result is equal to F string and say one dot 2, like that. And if I say results, what does that do? And then if I say float result, does that work? There we go. Okay, so that there's probably, it's a little bit sloppy, but I think this will work. Less sloppy is okay. So basically, I'll just convert the dollar into a string here, and the cent into a string like this. That looks correct. Dollar. Why does that look? Oh, these are the values passed in. I need to put a, there we go, put a in quote. And then I think I can just say float. So we'll just say create or float res like this. And again, I could clean this up later, but basically this would be float result. And then I can just put that into my change algorithm, right? Because we know that this thing will take a, this will take a float. So we'll say, we'll say change made will equal to greedy change of the float result, like that. And then I can return back change made, just like that. So in theory, this should work. Let's see here if this works. So I will open up the terminal, run this again, and go back to my web preview, and we'll paste this in, and we'll say change, and we'll put in $4.52. There we go. 18 quarters, 1 penny. Let's try a different change amount, and we can say $2.23. Right, 8 quarters. Let's do $1.37. 5 quarters, 1 dime. So now we've got a web service that returns back the business intelligence results. In this case, it's a somewhat straightforward business intelligence solution. So what I'm going to do then is I'm going to make this into something I can deploy to my customers, right, in my company. So this is okay that I have this, running in the terminal, but actually to make it much more useful, let's deploy this somewhere. So how would I do this? So I think, again, I have the documentation here. I just say, we don't have any libraries or anything, which is great. I can just say deploy, and I think it's just, deploy, just like that. So I will go back here and just run this command, gcloud app deploy, and we can make a production web server. So it says, do you want to deploy it? And look, it'll put it into this URL. And so anybody can use it, including you. You can use this as soon as I deploy it. So we'll say yes. There we go. So it's going to upload. I think it typically takes like 2 or 3 minutes the first time you do a deployment. Although I don't think there's a lot of files here, so hopefully it's quick. Yeah, I think it'll take 2-3 minutes. That's typically the amount of time that it takes. So I guess while this is waiting, I guess the summary that I'll say is that what's important, and maybe let me just sum this up. I'll just sketch this because it'll take a couple minutes to deploy. So what are we doing, and why do we do it, and what problem does it solve? So let's get into that. So a recap here is recap of optimization. So as we discussed, it's easy to get stuck when you're building business intelligence tools, but we know that there is a spreadsheet solution that is completely okay. You can use a spreadsheet, and it's a great tool. You also can use symbolic or mathematical notation. So we'll just call that notation. Or you can do Python. They're all fine. They're all good ways to solve a problem for BI. We'll call this BI optimization. And if you're working as a business intelligence professional, you probably will have to encounter all three at some point in your life, and it's good to just be able to go back and forth, and that might be a good place to practice is kind of going back and forth. Okay, and then that's concept one. The second concept that we went over was this idea of a good enough solution, and this is really the real world, right? So if we take, unfortunately, I have to use this as an example. In the United States, I think it was in February or March, the president said that COVID-19 is fake. It won't solve. There is no virus, but instead of just pretending it didn't exist, they could have come up with a good enough optimization. And the good enough optimization could be, look, we can't completely solve the problem, but we'll try our best. Let me just drink a little water. But we'll try our best with something. We'll try our best with a good enough solution, and the good enough solutions maybe could have been, test major cities, block travel, things like this. So these are these are basically saying, look, I can't come up with a perfect solution, but I can come up with something that's good enough. Same thing with traveling salesman problem, is that the random start with a shortest path plus shortest path. These are all great examples of how you can come up with a good enough solution. So this is just in the real world. A lot of times it's either too complex to solve in your head, or there is no good solution. And so your intuition of avoiding things that are super linear, right? And in general, you want to be below this line. Like you want to be down here, right? So you either want to be, you don't want to be up here. This is the bad part, is you come up with solutions that either never get solved or take forever to solve. And so ideally you can come up with solutions that are either fixed, O to the 1, or, are between the O to the n and O to the 1 right here, so that that there's a decent runtime here. And that's in general the concept. And then the third thing that we got into was, once you start building these solutions out, in this case we use a change machine, but it could be anything. It could be traveling salesman, it could be some other heuristic or optimization. You can build out a web service very easily with even limited knowledge of Python. You can build out a web service using a cloud provider. And in this case, we're using something called Flask, and we're using GCP, Google Cloud Platform. But it could be anything. It could be Node, it could be AWS, it could be Azure, it could be AliCloud, it could be wherever. A lot of times, if you want to get your business intelligence solution to a customer quickly, you need to turn it into a web service, right? So those are the three concepts that we went over. So let's now look back at our web service, and hopefully it has been deployed. It is. Okay, perfect. So what's incredible about this is that we can go here, and anybody can do this. So any of you can do the same thing. You can just go to this URL, which is https change-machine.uc.r.appspot.com, and you can test that out as well. So let's go here and let's type this in. And that's funny, it's got a problem. Let's see here. Let's see if this works. Did not. Maybe there's a problem deploying it, which is common. Oh, I know what the problem is actually, is that I believe we didn't give it Flask in a requirements file. When you deploy your application with Google App Engine, one of the things that it wants is a requirements file. And because we didn't use Flask like this, I think that's what the issue is. So I can try it again here. Let's see. If we can't fix it, it's not the end of the world. But I believe that you need to do a requirements file, if I remember correctly, which is the list of the packages that the application needs. And so if I go through here and I just put in Flask, and I say make install, or I say pip install -r requirements, we can just double check that this works. Okay, and then if I run this again, does this work with our Flask app? Yeah, it looks like it works. So I think I just need to redeploy this, which G Cloud. Let's just look at the history. There you go, G Cloud app deploy. Yeah, I believe it needs the file main.py. It needs the app.yaml, and it also needs the requirements file. I believe that that is the issue. Let's see if this works. And while that's running, I can just look at the documentation real quick. We can just say Google Cloud, Google App Engine, Python Hello World, Google App Engine, Python Hello World, and quick start. Let's just double check what it requires. I think it requires, so we need this, we need the project. Okay, create the project. You need to download. It's recommended you have this, download this, okay. CD, app deploy. So I think it needs, what it's saying is to prepare your Google Cloud, install App Engine. We would have to look at this example and see what's inside. I think it's just we weren't including. If I look at App Engine here, standard Python 3, they have a whole bunch of different examples. Here we go, Hello World. That's what I care about. Look, so it needs app. So we just know that it needs this. It needs the app.yaml. It needs a requirements. There we go. And it needs the file, the main file. So I think that's what I was missing. And so let's try it again. Did it work? Okay. Hopefully this works this time. And there we go. So it didn't know what library to install. So now let's go ahead and test this out. And we'll say change, and we'll say $4.68. There we go. So now we have a publicly available web service that our customers can use.